This is the third in a series of videos on probability. And in this video, what we're going to do is we're going to take a problem which is not ELO and try to convert it to one that is. And this is a trick that doesn't always work, but works sometimes. So let's do this. Here's our experiment that we're going to roll 2 dice and we're going to add up the faces. So, for example, if we get a 5 and a 4, then we're going to add those together and we're going to say that our result is a 9. And if you think about that, then if you roll 2 dice, then what happens is there's these possibilities, a 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. But not all of these are equally likely. And I'm hoping that that kind of just makes intuitive sense there. Since it's not ELO, then we can't simply use this formula here, right? That's only for when experiments are ELO. So what we're going to do is we're going to change the problem. And the key to this is even though we're going to change the problem in our head, the actual physical action's the same, so the answers have to be the same. So here's the new experiment. The new experiment is you're going to roll 1 die, write down the answer, then roll another die. And let's call this experiment N for new. And let's do the sample space. The sample space is all the different possible outcomes. Well, before, when we rolled 2 dice and added up, the outcomes were 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But here, since we're rolling 1 dice and writing down the answer, rolling another dice, our results are going to be a 1 and then a 1, a 1 and then a 2, a 1 and then a 3, a 1 and then a 4, all the way to a 6 and then a 5, a 6 and then a 6. And I didn't list them all out, but if you list them out, there's 36 possible outcomes. The key, if you do that, is now this new experiment is ELO. And since it's ELO, then you can apply the formula where the probability of A is equal to the number of times A occurs in the total number of outcomes in the sample space. And the total number of outcomes in this new sample space is 36. So let's just do a couple of examples here. So what's the probability with 2 dice that the sum is 10? Well, you know the denominator is 36. If we use this formulation now, then we have an ELO problem, right? And so the denominator is 36. And the 10, how can you get a 10? Well, you can get a 10 by rolling a 4 and a 6 and a 4, or a 5 and a 5. So you have a total of 1, 2, 3 different possible outcomes. So it's 3 out of 36, or 1/12 is your probability. And it's fine to convert this into decimal or percents. In fact, most people do. Let's do another one. What's the probability that the sum is 5? The denominator again is 36. Again, this is the key. The key is we're using this formulation. Even though, in fact, we're rolling 2 dice and just add them up, we're going to pretend that we roll 1 dice, write it down, roll another dice, write it down, because if we do pretend that that's what's happening, then we have an ELO problem. The probability that you roll the sum is 5 will be something over 36, and how many different ways can you roll a 5? Well, you can get a 1 and a 4 and a 1, a 2 and a 3 and a 2. I think that's it. That's it. So you get 4 out of 36, or 1/9. And the most famous one is the probability the sum is 7. Again, over 36. 7, you get a 1/6, 6/1, 5/2, 2/5, 3/4, 4/3, 1, 2, 3, 4, 5, 6, 6, or 1 out of 6. And that's how you convert a problem that's not ELO into a problem that's ELO. And that's a very important trick. It doesn't always work, but when it works, it really simplifies your math. In the next video, we'll talk about probability distributions, which is an alternative way to solve problems when they're not ELO.